Eventually going to talk about the reciprocal function and furthermore the rational functions and their graphs. Before, I just want to take a quick reminder of doing some long division here and how we make the result look, or what we can have the result look like when there is a remainder. So if I wanted to do long division on this problem, right, I can do x minus 4 into 3x minus 7, and it looks like that's just going to be 3 times, so that's 3x minus 12, and subtract. Gives me 7 minus a negative 12 is a positive 5. So what do I do with the 3 and the 5? Well, the answer is going to be 3 plus the remainder 5 over what I originally tried to divide. So we'll just keep that in mind as we move on. Now, we're going to look at this function called the reciprocal function. And we're just going to analyze the best we can here. And you'll see I've got a graph here. The reciprocal function looks like that. So that's the basic, just 1 over x. And I believe these parts of the graph go on forever. So those are some arrows that we have to analyze. So it looks to me like this graph has a horizontal asymptote of y equals 0 and a vertical asymptote of x equals 0. We could have seen that by the original function. Note that at any time if I put a 0 in for x, I get 1 divided by 0, and that's undefined. We can't do that. We say that x is 0 is not in our domain, and we can look at that and know that we have a vertical asymptote at x equals 0. So let's look at the horizontal asymptote first. So what this is saying is that I put in values for x larger and larger and larger. So as x goes to infinity, f of x, or y, approaches 0. It gets closer and closer to 0, but never gets there. And likewise, back here, as x goes to negative infinity, f of x goes to 0. It'll change for us. Now let's make sure we understand the limit notation. So this says the limit of f of x as x goes to infinity equals 0. Notice where I got the infinity from, where I got the 0 from. And down here, we know that the limit of f of x as x went to infinity, negative infinity, the output was still 0. So now a little different. We're going to go analyze this arrow here. All right. So notice now it's the output that's going. The output is going to infinity. So I know that this is going to infinity. I know that's an infinity, but what's x approaching? And what we see is that x is going the other direction here. It's getting closer and closer to 0, but it never gets there. So x is approaching 0. The output is negative infinity. Down here, the same thing. The limit of f of x, I realize that the output, right, it just keeps going down to negative infinity. But it's as x goes to, what's happening to my x values, or the x coordinate of these points, it's approaching 0. Now the problem is, those two things I just wrote down are, the limit as x goes to 0 is negative infinity, and this one says limit as x goes to 0 is positive infinity, so we have to distinguish. Now this one, we're just going to put a plus sign up there to say that we're approaching 0 from the right. And then down here, we're going to put a negative sign there because we're approaching 0 from the left. All right. So you can digest that for a little while. So now we're going to look at this. All right. If we have the function 1 over f of x, next thing we're going to do is what happens if we start multiplying the output by a number, adding a number to the output, or adding or subtracting a number from the input. And hopefully you know these already, but let's quickly go to my graph. All right. And there's my graph. All right. Notice I have a plus sign there. All right, that's 1 over x. So I'm going to change that to just dotted. So that's my base function. And now I'm going to put in this new function. Well, how did I get there? All right, let's go back again. So if this is what I want to see, how do I make those changes, A, B, and C, to the baseline? So this is, instead of inputting x, I'm inputting x minus b. So x minus b goes there. I'm multiplying that by a, and I'm adding c. So that's the graph I want to analyze. And we'll go back here, and we'll go ahead and put in that graph. All right. And the first thing I'm going to do is I'm going to change a. So here's a. So what number am I changing? All right. If a is greater than 1, hopefully you see, just like before, it's a stretch in the vertical direction. We're taking every point on the graph and pulling away from the x-axis. Okay. Now I'm going to go back to a as 1, so it doesn't affect the graph. Then how about a between 1 and 0? That's going to be a shrink, pulling all the points closer to the x-axis. And then hopefully no surprise here, if I make a negative, we got a flip. So the area in the first quadrant just went down to the fourth quadrant, and the part of the graph that was in the third quadrant went up to the second quadrant. You might want to replay that, go through it, put a back to 1. Now b, that looks like we're messing with the input, so I think it's going to move the graph left and right. And not only that, is it moving the graph left or right, everything, it's moving that x asymptote, or the vertical asymptote. So b is 4, looks to me like the vertical asymptote is at x equals 4. When b is negative 3, or negative 3, it looks like the vertical asymptote's at negative 3. All right, so let's put b back at 0, so it's not affecting. And then c, no surprise, it's going to move the graph up and down. And more specifically, it's moving the y-intercept, or the horizontal asymptote. It's moving up and down. So when c is negative 3, the horizontal asymptote is at, or this is negative 4. So horizontal asymptote is at y equals negative 4. If I go up to 6, now the horizontal asymptote is at y equals 6. So let's just move them both. Let's use 3 and 6, and we'll leave a at 1 here. All right, so if we go back to our notes, all right, we know that C, changing just in reverse order, C moves or slides up or down. Changing B, slides left, right. And A, it either flips if A is negative, or it stretches. Okay. So let's see how we use that in our daily life here. So negative 3, x minus 1. So let's put that, realize that this is actually negative 3 times 1 over x minus 1. And I'm going to put plus 0 here. So what that tells me right away is that my horizontal asymptote is y equals 0. My vertical asymptote is x equals 1. And I know that I have a stretch here, but that negative sign right there means the graph flips. So if I would just want to sketch that, all I'm going to do is sketch the asymptotes. So here's the vertical asymptote, x equals 1. Horizontal asymptote, y equals 0. All right. And because the graph flipped, I know that my graph is going to be in the second quadrant and the fourth quadrant. All right. And now analyzing the arrows right here, as x goes to infinity, f of x goes to 0, gets closer and closer to 0. Back here, as x goes to negative infinity, f of x approaches 0. Okay, this arrow says as x approaches, now 1, that's my vertical asymptote, 1 from the right, f of x goes to infinity. And this one says as x approaches, oh, which one's right? This is as x approaches 1 from the right. Then f of x goes to negative infinity, and I got to go back and correct this one. It's from the left, right? So from the left, from the right. And then I'll just do one of these. Remember, if you change it into limit notation, you use that. X approaches 1 from the left equals infinity. And then I'll let you do all the others. Right. Moving along, what if we had this? All right. Now this doesn't appear algebraically like a reciprocal function, but in fact it is. Remember what I started the activity with is we did long division. I got 3 plus 5 over x minus 4. Okay, so when I do that, I get 3 plus 5 over x minus 4. Remember, I like this f of x, actually, a times 1 over x minus b plus c. I can make this look like what we dealt with. I can take that 3 and put it at the end, still a positive 3. I can add it in any order. X minus 4 is still my denominator, but instead of having 5, I'll put a 1 there, and I'll multiply by 5 out front. So now that means 3 means y equals 3 is my horizontal asymptote. X equals 4 is my vertical asymptote. And 5 tells me there's a stretch, but more importantly, since 5 is greater than 0, I know that there is no flip. So knowing that information, I can come here really quickly and sketch. Vertical asymptote, x equals 4. Horizontal asymptote, y equals 3. It doesn't flip, so I know it's just the base function, something like that. And I'll pick out a couple of these arrows and describe them. That arrow means as x goes to infinity, f of x approaches 3. In limit notation, this is the limit as x goes to infinity, f of x equals 3. And then I'll take this arrow. So as x approaches 4 from the left, f of x goes to negative infinity. And in limit notation, as the limit as x approaches 4 from the left of f of x, the output is negative infinity.